I'm Sarah Aliwat, and I'll be guiding you through today's presentation. Deep Tech Talks is our regular online series designed to inspire and engage by connecting government, industry, and academia and startups in meaningful conversations that shape the future of innovation. Over the past weeks, we've explored how emerging technologies from artificial intelligence and biotechnology to quantum computing and advanced materials are transforming industries, economies, and societies worldwide. As we close this season, we are thrilled to host a presentation on the theme Generative AI in Deep Tech Era, What You Need to Know. Delivering this session is Bahae Eddine HALIM, co-founder and CTO of XAI and founder of Moroccan Data Science. In this talk, Bahae will share key insights on how generative AI is reshaping the deep tech landscape and what challenges and opportunities it presents, and what every innovator, policymaker, and entrepreneur needs to understand to harness its potential. Now I'm delighted to hand it over to Bahae Eddine HALIM to begin this presentation.
Yes, thank you, Sarah. I'm just checking the YouTube live stream. I don't know if it's on or not, but I can find this. Because I have some friends that want to assist and they can't join us here. Okay. Can you help me please to check? Because I am here in the YouTube channel. That's it, right? Sarah?
Yes.
This is your YouTube channel,
Yes.
right?
Yes.
I can't find this thing. Or we can go without YouTube, but just if you have things live, just to check.
The session is being recorded. It's gonna be posted
all right,
later.
all right. It's not streamed. All right, all right. I see. Now I remember.
And
All right. So hi everyone. Good morning. Good evening, everyone. To those here in Dubai and to everyone joining us remotely. Thank you for being a part of the Deep Tech Talks. My name is Bahae Eddine HALIM, and it's a true honor to be with you today. I'm the co-founder and CTO of XAI and also a co-founder of the Moroccan Data Scientist community. Over the next 40 minutes, we are going to explore one of the most exciting intersections in technology today, generative AI in the deep tech era. We will break down what you need to know, what's real and what's next. My professional life is driven by two passions at XAI. My focus is on building enterprise-grade AI solutions with the Moroccan data scientists or MDS. And my focus is on building communities. These intersections of technology and people is exactly why I'm so passionate about this topic. This is not just about algorithms or hardware. It's about how we as engineers, researchers, and leaders can come together to solve meaningful problems. My personal motto is in AI we trust data we thrive today. Today, I want to show you how we can do that by building the future together. Every few years, a technology arrives that changes everything. We saw it with the internet, with the mobile, and with the cloud. Today, we are standing at the dawn of the next great platform shift, the generative AI era. This is not just an incremental improvement. We are talking about a fundamental change in how we interact with machines and how machines interact with the world. The numbers are staggering. Market projection estimates 1.3 trillion opportunity by 2000. But this is bigger than market size. For the first time in history, we have tools that can create and design and invent alongside us. Here we're gonna see the two revolutions converging. We have the first one, the creative revolution, and second one, the scientific revolution. To truly grasp these moments, we must understand that we are living through two simultaneous revolutions. On one hand, we have the creative revolution powered by generative AI. This is the world of language model, LLM, image generators, VLM, is your large model, and code assistants, like tools like, for example, GitHub Copilot, like Kilo Code, like Augment Code, like Try, like we have lots of EDE, integrated development environments, and we have also some SaaS on the market, like the V0 by Vercel, we have Board, we have Lovable, etc. AI that can create novel digital concepts. And on the second hand, or the other hand, we have the scientific revolution driven by deep tech. This is the work of fundamental breakthroughs in fields like biotechnology, quantum computing, and advanced materials. Understanding them separately is the key, but understanding their fusion, that is the secret to seeing the future. So now let's start with the first item. What is generative AI? So, and its core, it's a creative engine. Unlike traditional AI that only analyzes or predicts, generative AI works in two steps. First step is learning the underlying patterns from massive data sets. All the text on the internet, millions of images, billions of lines of code. Then it uses that knowledge to create something entirely new and original. That is the machine learning. We have lots of data sets. We have the supervised learning, the unsupervised learning, and then the reinforcement learning, and then we create a model that can predict, that can create original content. So think of it like a master artist who can create a masterpiece on command after studying millions of previous works. Just if you want, you can go to this article later. You can take a screen. It's called "Does Data Improve Creativity?" It's a good article and the recent one. Here we are talking about the paradox of constraints and creativity. Also, we are talking about data-driven iteration, tool for creative refinements, the creative data loop. This is so important, this loop, if we can understand it. We have the hypothesis, generate an initial idea or prototype, then make the estimation, the analytics, the measurements, collect data on performance, usability, or other key indicators. So after that, the insights, analyze data to spot patterns, and accept results or area for improvement. Then we make the refinements or enhancements. Use these insights to refine the concept, adding fresh creative elements, or removing ineffective components. Then the loop, we call it the creative data loop, or that is something essential for any data-driven project. That's the agility, the scrum of the new project, new startups. Then retest, then launch the updated solutions and user again. Now let's look under the hood. This creative magic is powered by sophisticated architectures. Two are domains. For language or NLP, natural language processing, we have transformers, the engine behind large language models or LLMs. Their superpower is a mechanism called self-attention. You can read a paper called Attention is All You Need by the laboratory of Google. It's called Deep Google. Yeah, this article is so good. Deep Think, Google Deep Think. This one. In 20, yeah. So we can read the abstract to understand a bit what is the transformers and what is LLMs. So the demand sequence transdictions model are based on complex recurrence or convolutional neural networks is an encoder-decoder configuration. The best performing models also connect the encoder and decoder through an attention mechanism. And we can, for example, go here and trying to understanding these diagrams to understand what is the transformers and or the self-attention mechanism. This allows the model to weight the importance of every word in a sentence relative to all other words, giving it a profound understanding of the context. That is the transformers, like this. We have input embedding, then we have the positional encoding, we have a self-attention of every token, multi-head attention, then we have the feed forward, then the output. For images, we have diffusion models. These are fascinating. They start with pure random noise. Here, this is a noise. And throughout an iterative denoising process, they progressively refine that noise step by step until a detailed, coherent image emerges. It's like a sculptor starting with a block of marble and slowly chipping away until a statue is revealed. It's the enhancement of affections. Now, for our second theta, the first one is the generative AI. The second one is the deep. This is the scientific foundation. Deep tech is not about the next social media app. It's about tackling humanity's biggest challenge with tangible scientific breakthrough. These ventures are built on years of R&D, research and developments in areas like biotechnology, quantum computing, clean energy, etc., where we are engineering new medicines, advanced robotics, which are transforming factorials and exploration, and quantum computing, which promise to solve problems currently impossible for even the fastest supercomputers. It's crucial to understand how these two revolutions differ. Generative AI's output is primarily digital content, text, images, code, etc. And Deep Tech output is physical product, new hardware, advanced materials, or biological systems. Uh, Here, for example, the core focus here is the data and algorithm. Here is the creative engine, pattern recognition, content generation, etc. And the output is this type of models, text, image, code, audio, video, etc. But the deep we can create hardware, materials. Uh, this is simple, but this is more advanced. And the fusion between the two systems is a bit difficult. Should be should have a creative mind and also a scientific mind. So what happens when the creative engine meets the scientific foundation? You get a supercharged innovation side. When the digital creativity of generative AI is applied to the physical challenges of the peak, the results are transformative. It becomes the ultimate R&D assistant. The research and the development cycles that once looked at decades can now be compressed into years or even months. Or, yeah. So we use the generative AI to give a power to the big technologies or revolution. So here in the part 3, the technical core, accelerating discoveries, right? For example, we have three mechanisms of acceleration. This acceleration is not magic. It's happened throughout three key mechanisms. First one, hypothesis generation. AI can analyze billions of scientific papers and data points to propose novel hypotheses that human researchers might have missed. Second, simulation and design. AI can simulate incredibly complex physical systems from protein interactions to airflow over a wing, dramatically reducing the need for costly physical. And the third is material and data discovery. AI can predict the properties of undiscovered materials or find the needle in the haystack pattern within massive genomic data. This fundamentally transformed the scientific method itself. The old way was a slow, linear pattern. This is the old way for innovation. We have an hypothesis formulated based on prior knowledge, laws, for example, in physics, in mechanics, etc., or biology. The experiments collect empirical data, interpret, make some analysis and interpretations, and now make a new question. It's a linear path. The new way is a rapid and iterative loop. We start with data, feed it to an AI model, an LLM, for example, to generate insights. Use those insights to design a highly targeted experiment. And the results of that experiment become new data. Feeding the loop again, AI and human experts collaborate in a continuous cycle of improvement. This is the agility. Here, a perfect example of this is the generative design, for example. This is a technical paradigm shift. The core concept is that design become goal-driven, not ship-driven. Okay. Instead of drawing a part in the CAD, ce sont conception assistée par ordinateur. In English, it's computer aided the design. Yeah. For like AutoCAD, SolidWorks, etc. You tell the AI the constraints I need, for example, you mix a prompt, for example, to a tool, AI tool. For example, you say, I need a bracket that supports this load weights less than this, is made from this material and connect these points. The AI using algorithms like topology optimization, then iterates through thousands or even millions of possible designs to find the one that is mathematically and physically optimal. The final form is often organic, counterintuitive, and far more efficient than what a human would have designed alone. Yeah. We have another use case. Let's make this real. In healthcare, for example, generative AI is revolutioning drug discovery, for example. A critical step is understanding how protein fall into 3D shapes, as this determines their function. In the past years ago, this was a grand challenge. Then come AI models like DeepMind AlphaFold, for example. They can now predict a protein structure with incredible accuracy in minutes. This allows scientists to design novel drugs that target specific protein with precision, potentially cutting the time to market for new medicine by years. In the energy sector, a huge priority for the Middle East and Africa region, AI is a game changer. We can create a digital twin of an entire wind farm. This virtual model, fed with real-time sensors data, allows an AI to simulate thousands of scenarios. It can predict maintenance needs before a part fails, adjust the angle of each blade to optimize for changing weather pattern, and ensure grid stability. We are also seeing AI used to screen thousands of candidate materials for more efficient solar cells and batteries. In manufacturing, the results are astonishing. On the left, here, you can compare this. On the left, you see a traditionally manufactured metal part. It's bulky, heavy, and wasteful. On the right, it's AI-generated counterpart. Using generative design, AI creates a part that is more lighter and more stronger with using less materials. This has massive implication for aerospace, automotive, and any industry where weight and strength are crucial. Now for one of the most complex challenges, semiconductors design or chip design. The field is called electronic design automation or EDA. The key problem is placement and routing P&M. Placement and routing. Imagine having a place billions of transistors on a chip smaller than your fingernail, and then wiring them all together in the most efficient way possible. It's a combinatorial problem of astronomical scale. This is where AI excels. Using techniques like reinforcement learning, We have, for example, system like Google AlphaShip can explore the design space far more effectively than humans, leading to chips that are smaller, faster, and more power efficient. Here is the thing. But with this immense power comes immense responsibility. This technology is a double-edged sword. It holds the promise of an utopian future, accelerating science and solving global challenges, but it also carries dystopian risks, misinformation, economic disruption, and loss of control. I think everyone here watched some movies like Planet of Apes or I, Robots by Will Smith, some futuristic movies that talk about the robots revolution. So yeah, the path we take is not predetermined. It's depend entirely on the collective choice we make today about how we fight, govern, and deploy these powerful tools. AI, ethics, AI, governance, etc. Yeah, the key technical and political challenge. We must be clear-eyed about these challenges. First, bias and safety. If the data we train AI on is based, HALIM said, the AI will be based. Second one, the black box problem. Many AI models make decisions we can't fully understand. In high stakes fields like medicine, that is not acceptable. Third, economic disruption. Automation will displace some jobs while creating others, requiring massive reskilling efforts. And finally, security. The same tools can be used to create deepfakes, for example, for cyber attacks or for design weapons. They use it now. You can make some AI wars, etc. To solve the black box problem, we turn to a crucial field called XAI, explainable. Yeah. We can't trust an AI diagnosis if it can't tell us why it made that diagnosis. XAI gives us tools to pick inside the box. We can use some techniques like local interpretable model agnostics explanations or sharply addictive explanations. They can help us understand which inputs features, and we call that features engineering. So it can help us to understand which features were most important for a model decision. For example, in a medical diagnosis, XAI can highlight that chest pain, for example, and age were the most critical factors, making the AI resonant, transparent, and audible. So we have here some raw data. We have some neural networks to train a model, and this model output is, for example, give us these results. For example, this lady, the age of the lady, the chest pain, yes, and the blood flow pressure and cholesterol. So the risk is high risk. So XAI explanation layers, chest pain, for example, give more priority than age. So the model identify critical risk factors, including advanced age combined with chest pain symptoms and elevated cholesterol level. Addressing these challenges is not just a responsibility, it's an opportunity. And it is an unprecedented opportunity for the MEA region, Middle East and Africa. For decades, our region has often been a consumer of technology. This platform shift allows us to leapfrog from being a technology adopter to a technology innovator in innovation. With a young tech-savvy population, ambitious national AI strategy, and growing investments, the MEA region is uniquely positioned to become a global hub for responsible, impactful AI and deep tech innovation. We have here the Global AI Index last year in the Arabic country. We have Saudi Arabia in first position, Emirates in second, etc. You can take also a screenshot to see later. So what does the future hold? We are moving toward a world of autonomous labs where AI design and run experiments 24 hours by 7. We will see the emergence of AI scientists, systems capable of making noble worthy discovery. Why not? Yeah, we have lots of project, open source project. We have this one lab something lab auto lab. I forget the name. It's lab. It's okay. It's okay. Laboratory automation. We have lots of open source project about automation. This is an open source Java based hospital information. Okay. And this will lead to an era of personalized everything, from medicine design, not for your specific DNA, to materials created on demand with unique properties. This is not science fiction. The early version of the systems exists today. Yeah, this is the future. Good chance. So, how do you prepare for yourself, for example, to adopt AI in company, businesses, startups, or on an individual stage? So for individuals, it's about cultivating to-shaped skills like deep expertise in your domain, that's a broad understanding of others. You should be multi-skills, polyvalent, okay? And focus on the uniquely human skills AI cannot replicate. For example, critical thinking, ethical judgment, and creative problem solving. And for businesses, don't try to boil the ocean. Start with small, high value pilot project. Later, you can be in your area, in your niche, sub-niche. Foster collaboration between AI experts and your domain specialties. That's where the magic happens. And most importantly, invest in upscaling your talents and your team. All right. Let's summarize all our talk because we have just 2 slides to finish this. First, fusion is the accelerator. The combination of generative AI and deep tech is compressing innovation cycles. Second, this transforms R&D from a linear path to a rapid iterative loop. Third, we must navigate challenges proactively, safely, and ethics, it's a must. And finally, the future is about human AI collaboration, amplifying our own capabilities. How will we choose? This brings me to my final thought. This technology is not something that is happening to us. It is a tool we are building. The real question is how we choose to shift it. And with that, I would love to open it up for discussion to get us started. I will pose a question to all of you. Which deep tech sector in the MEA region do you believe will be most transformed by generative AI in the next 5 years? Please feel free to share your thoughts, raise your hand, or connect with me on LinkedIn by scanning this QR code. Let's start the conversation. Go ahead. Sarah, are you here? Someone of the organization team, please.
I'm here, yes. I think Dua has a question.
Yes, I don't have a question. I want to just say thank you to Sir Bahae Eddine for this meeting about Gen AI. So thank you, Sir Bahae Eddine.
Welcome. It's my honor.
So thank you so much, Baha, for such an insightful and inspiring presentation. And everyone who joined us today, we truly appreciate your time and participation. So this has been Deep Tech Talks 2025, our weekly series powered by the Global Innovation Entrepreneurship Company, where we've explored the technologies and ideas shaping the future. As this is marks our final session of the season, we want to thank you for being part of this journey with us. Until we meet again, I'm Sarah Aliwat. Thank you once again, and we look forward to welcoming you to our future Deep Tech MEA initiative. Have a wonderful evening.